Today I'm going to talk about something closer to the theme of this meeting, which is, you know, a question basically at the interface between language and conceptual understanding. And it's a piece of work that I've been working out in collaboration with Felix and several other people over a couple, 3 years now, since a workshop that was organized by this man, Henry Schitze. So let me just describe my overall perspective and try to come to the point quickly here. So first of all, I'm always coming from my very PDP-centric set of principles, which are articulated in their briefest possible form here. The first and starting principle for me has always been mutual constraint satisfaction. So what does that mean? It means that all elements of anything we're trying to process, perceive, or understand are mutually constraining each other. And this little example in the lower right-hand corner illustrates this, I think, very nicely. If you read these two sentences, you see Jack and Jill went up the hill, then you see the pole vault was the last event, but it turns out that the handwriting for event and went are exactly the same handwriting, and you just see them as the appropriate word in context because you're using all the rest of the information in the context to help you figure out what that word is. So we think it's mutual. This is Rumelhart's initial idea that each word constrains every other and each at all levels of analysis simultaneously. So that's the whole interactive activation, parallel distributed processing view. The second fundamental principle is distributed representation. We use patterns of activation everywhere, and Ellman's simple recurrent network is an example of that. Instead of having, you know, localist items for concepts, he used patterns. You know, in these models, structure sensitivity to things that linguists like to write rules about emerges through a connection-based learning process, and so does the organization of representation. So this is the thing you see on the right of this slide is just Ellman's initial demonstration that simply training his simple recurrent network to predict the next word in simple sentences led it to discover that taxonomic categories of nouns and verbs, and within those subcategories, which might be thought of as linguistic, sort of, you know, like takes a direct object or not, but might also be thought of as semantic. And animacy is one of those is animacy syntactic or semantic? Well, I think things are ultimately semantic and that the syntax essentially follows from that. So in some sense, I'm a generative semanticist, but we'll get to that. So here's the problem. Ellman's simple recurrent network had this problem really badly, but other later models still had it up until 2015. And this is the problem of a limited window of context. So if we read a little passage like this, John put some beer in a cooler and went out with his friends to play volleyball. Soon after he left, someone took the beer out of the cooler. John and his friends were thirsty after the game and went back to his place for some beers. When John opened the cooler, he discovered that the beer was gone. You all knew that, right? And the context is coming from way before. And the problem is that even neural networks with LSTMs in them, you know, they have hidden layers, but they can gate stuff in and out, but they still have a limited bottleneck. So the solution to this, Gary, you're already telling me I'm out of time? If so,
oh, no, you're good. You're good.
Okay. So here's the solution, and many of you know this, but maybe not all. The reason why GPT-3 and all these other models work is because they're not passing information through a narrow bottleneck. When you're processing a given word, like here we have a sentence, John hit the ball with the bat. You're processing the word bat. You want to know, is it a baseball bat or a flying bat? Well, you can issue a query back to all the words in the preceding context. You could keep a buffer of context up to 3,200 words or so in available for querying like this, and therefore you can find out what's there, use the information in the context in this really interesting way to get a weighted sum of all the clues in the context, and then you get this thing out called a weighted attention vector, which is sort of like integrating information across all the prior contexts. And that gives you a tremendous amount of additional leverage in using context effectively. So another really cool innovation, which ties in with Rumelhart's thinking, and which I just like, when I first sort of understood it, it kind of blew my mind, was the idea that for each word in a, let's say, 2-sentence long stretch of text, each word is simultaneously querying all the other words in the whole block. I'm not going to go through the slide for a lack of time, but the basic idea is we're trying to understand this word bank here. Is it a financial institution or the side of a river? We can query all the other words in parallel, and all the other words are simultaneously querying all the other words. And we iterate this over 12 layers, and this is how BERT essentially learns how to use context to constrain its determination of what words are present and what their, as a consequence, what their meaning should be in context. However, this is all intralinguistic, right? And this is the extension of this that I feel is needed is for us to think that what we're doing as human beings is building situation representations. And, you know, you could compare this to a language of thought kind of thing, but I don't like to think about it in, you know, explicitly symbolic terms, the way most language of thought models actually look. So it's like an emergent sort of situation representation, right? What is a situation? Well, a situation in the world is a set of objects and their relations and or changes in their relations, like John hit the ball, in a context. Maybe he's a batter in the 9th inning when his home team is 2 runs behind and there's 2 outs, right? And there's 2 men on base. So if he hits a home run, they win the game. But in any case, you know, we're always building models of situations. So it's related to mental models thinking. And language is just our vehicle for expressing information about this. So my idea here, and in the interest of time, I'm going to move on to the brain basis of this, is to sort of take the ideas from this mutual attention work and extend them, because not only we want to imagine that language and other sources of information mutually constrain our understanding. So here is my construal of the understanding system in the brain. And you'll notice that there's no box called situation, because I think of the situation as being, the representation of the situation as being an emergent pattern of activation that's distributed across part of the brain that's especially important for object representation, another for, I would actually almost say relational information, because actually both parts says 9 minutes left. Thanks, Gary, that's good. 1 minute left, I understand. Both, it turns out that if you have damage to the object part of the brain, you lose your knowledge, you lose your words for objects. And if you have damage to the language part of the brain, you only have preserved the words for objects, right? So these 2 parts of the brain are both controlling aspects of language in different ways. So you might just call it objects and relations. But I thought that was a little radical. But then this all exists in a context, which many authors are arguing these days, like the Hassan Lab in particular, is talking about this idea that there's a slightly more temporally extended global context that integrates information over micro situations that occur rapidly in time. And then we also need our medial temporal lobes to help us with information that was presented somewhat earlier. So remember about that beer that those guys wanted to drink? Well, that's, by now, that's well out of your active current state in your cortex. You need your hippocampus to re-access that information, but you have it, so you can. So the short version of the story is that the brain seems to have systems like this that are all engaged in a mutual constraint satisfaction process, which I think the BERT style model of, mutual attention where everything attends to everything else should be extended, so that when you're building representations of objects, you're asking about what's in the language and vice versa. You're querying the context, and that's querying these other things. And I will stop there. Phew.
Great. So we've got about 4 minutes. Questions?
AJ?
Yeah.
This was great, and also resonates a lot with my thought, at least about the brain bases. But I want to extend what you said about the brain to go back to the kinds of tests you pose to the networks. And I think people like Gary Marcus, have been criticizing GPT-2, saying it can't do math, it can't do theory of mind, it can't do all of those things that now GPT-3 might do. I think these are just the wrong tests, and these are not fair tests to pose to a linguistic system, because we know in the human mind, linguistic computations have nothing to do with all of those processes. And so even if GPT-3 can do them, I don't know what it says about the human mind. And just to extend a little bit, just to mention, I don't think it's just the medial temporal lobe. There's a very broad neocortical system, the default mode network, that constructs event representation and is very sensitive to context and event appraisal and stuff like that. The language network, in contrast, seems to only be sensitive to context around 7 or 8 words. And after that, it plateaus, and it seems to not matter at all what happens beyond that.
Okay, so I think we agree about a lot of this. And just to clarify, what I called context there includes the default mode network ideas that you're referring to. And that is the more global sort of situation within which the micro situation of the bat hitting the ball is a momentary instance. So in our paper, we actually talk about this idea of like, okay, each micro situation is maybe an image and a small sentence that comes with it, or we could, for the sake of simulation, we could build something like that, but we need a more global context to. But that only encompasses up to 30 seconds to a minute or so of context, unless there's a real strong maintenance of a thread, whereas it remains sort of relevant throughout, right? And it sort of stays in the context. But yeah, so the hippocampus is needed when you've switched contexts. I think it's really interesting. It relates to Stan DeHane's talk. Maybe you're a disciple of Stan's thinking. What you're saying about mathematical cognition being a whole different kind of cognition. I think his work on that is provocative and interesting. However, I guess I believe that very similar principles apply there. In particular, this notion that language works together with the environment is something that I guess I didn't emphasize as much as I would like to have. But, when somebody says that's a numbat and it eats termites, the language is telling you what it eats, but you see the picture of the thing, and together this, and what Dedry was saying, yes, some things there's no picture for, other things there's just the picture. It's a complete continuum across all this stuff. And we're getting mutual information from both directions, right? When it comes to like number, we need the environment to structure us. We need the teaching signal somehow to say, oh, look, we want to see that this set here and this set here have something in common. Namely, they have the same number of objects, right? And this concept of sameness that Dedry was talking about seems to be very integral there. But anyway, so I think that the same principles apply, and why there's this sort of sense of a division of like mathematical structure from ordinary linguistic understanding, I'm still very intrigued by it. Or I wouldn't say linguistic, sort of situation understanding, right?